Hey, cool kids and cool cats. It's Coach Scott here. Let's start talking about chemical equations. All right, so here we go. Now we're getting into real chemistry here. I love it. I love it. I love it. So, chemical equations. Now, if we look at the chemical equations, these are representations of what we see with the chemical reactions. So when we burn gas on a stove, we're taking methane, CH4, in a gaseous state. Okay, under heat, we're combining them with two oxygens in a gaseous state. And we've rearranged the atoms around to where they're two new substances. We moved the two of the oxygens into the carbon, so we have one carbon dioxide in a gaseous state, plus two water molecules in our moles in the gaseous state. We're just moving stuff around. Cool, huh? So, some things we need to know about a reaction or an equation. Okay, a chemical equation, and all it is a recipe. The formulas of the reactants are on the left. So we call the left-hand side of the equation the reactant size. And we have an arrow that connects them with the formulas of the products, the right-hand side. So to write our word equations, we're going to write the names of the reactants to the left of the arrow. Then we're going to separate them by the plus sign. Then we'll write the names of the products to the right side of the arrow and separate those also by the plus sign. Not hard. So we have some symbols, some symbology that mean things when we write a chemical equation. The arrow means yields, and it separates the reactants from the products. A double arrow going one way or the other is the yield sign for a reversible reaction. So the material will be converted into products, and at the same time, the products are converted into the reactants. If you see a subscript S, that means that the product or the reactant is in the solid state, and we place this after the formula. The L, if you see a subscript L, that means that the reactant or the product is in the liquid state. And again, we place this after the formula. The G means that the reactant or the product is in the gaseous state. AQ is something new from some of you guys. And what that means is that the reactant or the product is in the aqueous state, or it's surrounded by water. Aqueous. So if you see an arrow with a little delta or a triangle on top or heat written out, that means heat is required by the reaction. So we heat the reactants up to make the products. If we see letters on top of the formula, okay, or it could be below it. Now this means, below the yield sign, this means that they're using a catalyst, or we're going to use a catalyst which is not consumed in the reaction to make the products. In this case, this is PT. You look on the periodic table, that is platinum. So the skeleton equation is a chemical equation that does not indicate the relative amounts of the reactants or products. So we're going to write the formulas of the reactants to the left of the yield sign and the formulas of the products to the right. So here is a word equation. Metallic iron reacts with oxygen in the air to produce iron 3 oxide or rust. Iron 3 oxide or rust. Okay, so the metallic iron, this is the word equation. Metallic iron reacts with oxygen in air to produce iron 3 oxide, otherwise known as rust. So I can write the little words out. Iron plus oxygen produces iron 3 oxide. That's a solid, that's a gas, and that's a solid. Now to write the skeleton equation, Fe is the symbol for iron. O2 is the symbol for oxygen. S and G, of course. Then Fe2O3 is the symbol for rust, or iron 3 oxide. Okay, so the word equation, another example, when ignited, methane gas reacts with oxygen gas to produce carbon dioxide and steam. So this is a skeleton equation. I've got CH4, methane gas, plus O2 gas yields CO2 gas and steam, or H2O gas. Notice this is not balanced, because how many O2s do I have? How many H2Os do I have? Well, you should have said 2. So, talk more about some more equations. Solid potassium chlorate decomposes in air to produce solid potassium chloride and oxygen gas. So, this is the word equation. Potassium chlorate, solid, yields potassium chloride, solid, plus oxygen, gas. So, we need to write the formula. We did this before Christmas, all right, before winter break. KClO3, potassium chlorate, might need to find those old ionic sheets, solid, yields KCl, potassium chloride, plus O2. That's potassium chloride. Let's think about it. Potassium's in group 2, chlorine are in group 1. Chlorine is in group 17, so it's got a +1, -1 charge. Y'all remember that. And it's going to have a KCl formula. So, we're going to practice here. Write the word equation, then the skeleton equation. Aluminum sulfate reacts with calcium chloride to produce calcium sulfate and aluminum chloride. I'll pause for a second and let you guys do that. So, let's see if I can write on this. Aluminum sulfate. Oh, got to pause a little bit because we messed up. Okay. Let's see if I can write. Okay, gotta get my pen going. We'll just go to the next slide and make it happen. Next slide, please. Well, nothing's working here, so we'll see how we make it. Okay, I think our technical difficulties are over with. Let's check it out. So, this would be the word equation, aluminum sulfate plus calcium chloride yields calcium sulfate and aluminum chloride. The skeleton equation, we've got to write the formula down, would be Al2SO4 3. Because sulfate has a +2 charge, aluminum has a -2 charge, aluminum has a +3 charge, crisscross. Y'all remember that, I hope. Cal plus CaCl2, again calcium +2, chlorine -1, crisscross, CaCl2. Same thing with the calcium sulfate, CaSO4 plus AlCl3. So all this comes from Lavoisier, Antoine Lavoisier. He said, this is called the law of conservation of mass. We may lay it down as an incontestable axiom that in all the operations of art and nature, nothing is created. An equal amount of matter exists before and after the experiment. Upon this principle, the whole art of performing chemical experiments depends. So let's look at some example. In the reaction, CH4 plus O2 yields CO2 plus H2O. What are the products? Right-hand side of the equation. So it's going to be water and carbon dioxide. So that would be B. We'll look at a couple more. in the reaction, those products are water. Let's see if that comes up right. Yeah, carbon dioxide and water. Okay, guys, that's it for tonight. Y'all have a good night. We'll see you tomorrow. And again, I think we'll have fun with chemical reactions. We'll be doing some labs. Life will be grand. All right, so this is Coach Scott saying have a good night. Bye.